In this tutorial, I will find the second derivative of these two functions we have on the board. Don't forget that whenever you are asked to find the second derivative of any given function, it simply means to differentiate the function the first time, and whatever value or product you get, then differentiate it the second time. That is what we meant by the term second derivative of a given function. Let's read out the question we have on the board. As we go ahead to solve, you will get to understand better. We have the question that says, find the second derivative of the following function. So number one part of the question is about f of x, which is equal to 3x in bracket x raised to the power of 4 plus 4. Before we go in detail in solving this question, I want to remind you that the first derivative of any given function is given by the y over the x. That is differentiating y with respect to x, okay? If you don't put it this way, you can as well put it as f prime of x. So this is equivalent to this, okay? Why the second derivative of any given function is given as the squared y all over the x squared. If you don't put it this way, this is still congruent to f prime prime of x. Don't forget that. Let's go ahead to find the second derivative of this given function we have here. Solution. For the first one, we have f of x, which is equal to 3x in bracket x raised to the power of 4 plus 4. Before we differentiate this function, let's first of all open up this bracket. And opening up the brackets here, we have that f of x is equal to 3x multiplied by x raised to the power of 4 will give us 3x raised to the power of 5. Because x multiplied by x raised to the power of 4 will give us x raised to the power of 5. Then plus 3x multiplied by 4 will give us 12x. Then let's go ahead to first of all differentiate this function the first time. So differentiating this function the first time, I will then say f prime of x. Remember, we are considering f of x, so I will use f prime of x. But assuming we change this equation to y equal to whatever we have here, I will use the y dx. But because we are not talking about the function y equal to just like that, we are just talking about the f prime of the f of x. That is why I had to use f prime of x here. So the first derivative, which is f prime of x, and that is equal to, then differentiating this, we have 3x raised to the power of 5, then we multiply it by the power of 5 and subtract 1 from the power. Then plus, here we have 12x raised to an invisible one. Remember, every natural variable has an invisible one attached to it. So that invisible one, we subtract 1 from it, okay? Such that this is equal to 5 multiplied by 3 will give us 15. Then x raised to the power of 5 minus 1 will give us 4. Then plus 12 x raised to the power of 1 minus 1 will give us 0. So solving further, we have 15x raised to the power of 4 plus 12 in brackets. Remember the basic law of indices, any number raised to the power of 0 is simply 1, okay? Such that we have 15x raised to the power of 4 plus 12 multiplied by 1 will give us 12. So the f prime of x is simply 15x raised to the power of 4 plus x plus 12. But we are asked to find the second derivative. That means we must differentiate this function the second time. So we have f prime prime of x. That is simply differentiating this derivative function the second time. That is the meaning of this f prime prime of x. Remember, I already stated it here. And that is equal to, when we differentiate this derivative function the second time, we have f prime prime of x, and that will be equal to 15x raised to the power of 4, then multiplied by the original power of 4. Then we subtract 1 from the power. Then plus, remember that when you differentiate a constant, it's simply 0, okay? So plus 0. and that is equal to 4 multiplied by 15 is very simple. 4 multiplied by 15. 4 multiplied by 5 will give us 20. We borrow 2. Then 4 multiplied by 1 is 4, plus this 2 is 6. So here we have 60 x raised to the power of 4 minus 1 will give us 3. Then plus 0. And adding 0 to everything here is still this, okay? So here is our second derivative. Therefore, f prime prime of x is equal to 60 x raised to the power of 3. Let's go ahead to solve the second one. The second one, we have f of x, which is equal to 4x plus 5. We want to find the second derivative of this given function. First thing first, let's differentiate this function the first time. So we have f prime of x, and that is equal to, here we have 4x raised to the invisible one. Every variable has an invisible one attached to it as the power, okay? Then minus 1, then plus, differentiating a constant will give us 0. 5 is a constant, so differentiating 5 will simply give us 0. And that is equal to 4x raised to the power of 1 minus 1 is 0. Okay? And remember that this is something as 4 in brackets. Any number raised to the power of 0 is 1. That is basic law of indices. And that is equal to 4. Because 4 multiplied by 1 is 4. But we are not asked to find the f prime of x. We are concerned with finding the second derivative of this given function. So we must differentiate this function the second time. And hence we have f prime prime of x, which means to differentiate this derivative function here. So differentiating 4 will simply give us 0. Don't forget that differentiating a constant will simply give us 0. What it means is that this 4 is like 4 is like 4x raised to the power of 0, such that we have, when we differentiate 4x raised to the power of 0, we have 0 multiplying 4x raised to the power of 0. Then we subtract 1 from the power. Then 0 multiplying everything we have here will still be 0. That is how we got the 0 here. So automatically, the second derivative of this given function is 0. This is how to find basically the second derivative of a given function. If you found this video useful, remember to reshare this video, and as well follow me on Facebook and also subscribe to my YouTube channel so that whenever I drop a new math content, you would be notified. Thank you and see you next time.